Hello everyone. 99% of the people will not be able to solve this problem. Our question is x square minus 1 whole square minus 2 whole square minus 3 whole square is equal to 4. Our job is to find out how many distinct real solutions are there to this question. This question was appeared in Oxford entrance exam. Many people did not able to solve it. By looking at the equation first we have to find out the degree of the polynomial. Multiply all the powers. So we have 2 into 2 into 2 into 2 is equal to 16. So we have 16 possible solutions, some are real imaginary and also repeated, so we want only the real solutions. So let's start. Square on both sides, then we have x square minus 1 whole square minus 2 whole square minus 3 is equal to minus 2 or plus 2. Minus 3 goes to right side, then we have x square minus 1 whole square minus 2 whole square is equal to minus 2 plus 3 or plus 2 plus 3. Then we have x square minus 1 whole square minus 2 whole square is equal to 1 or 5. Now again square on both sides, then we have x square minus 1 whole square minus 2 is equal to square root 1 or minus square root 1 or square root 5 or minus square root 5. Square root 1 is 1. Minus 2 comes to right side, then we have x square minus 1 whole square is equal to 1 plus 2 or minus 1 plus 2. Or 2 plus root 5 or 2 minus root 5. Then we have x square minus 1 whole square is equal to 3. Or 1. Or 2 plus root 5 or 2 minus root 5. But we want only the real solution, so square of any number will be non-negative, so we have to take only the positive values. So the roots 1 and 3 and 2 plus root 5 will be greater than 0. Now take 2 minus square root 5. Root 5 will be greater than root 4. So root 4 is 2. Now root 5 will be greater than 2. Now take 3 in place of root 5, then we get minus 1, which is less than 0. 2 minus square root 5 is a complex number because square of a number is less than 0, so it is a complex number, so we shouldn't take into account. Now square on both sides, then we get as x square minus 1 is equal to minus 1. R1, R root 3, R minus root 3, R plus root 2 plus root 5, R minus root 2 plus root 5. Minus 1 comes to right side, then we have x square is equal to 0 or 2 or 1 minus root 3. R1 plus root 3, R1 plus root 2 plus root 5. Or 1 minus root 2 plus root 5. Now 1 minus square root 3 is less than 0, and also 1 minus root 2 plus root 5 is also less than 0 because they are imaginary numbers. Then we have x square is equal to 0 or 2. Or 1 plus root 3 or 1 plus square root 2 plus root 5. Then x is equal to 0 or plus or minus root 2. R plus R minus 1 plus root 3 or plus R minus square root of 1 plus square root 2 plus square root 5. So here we have 1 root and 2 roots and 2 roots and 2 roots. If we add them all we get a 7, so there are 7 distinct real solutions are there. Hope you understand this problem very clearly. Thanks for watching. Please don't forget to subscribe.